Good day, class. Today we will talk about scientific notation. But before we proceed, I have a question for you. So, did you know the feeling of moving from a place to another? What do you think? We have different feelings when it comes to moving from a place to another. So, for me, if I'm going to move from a place to another, I have to be excited, yeah, because I may be able to explore new things, to discover something new, and to experience the things that I am not able to experience. So, those are things that may happen. But in your case, that you need to move from your place to another place, so what are you going to do is to do so. You have to move. But I am sure that you are able to go back to the place where you are right now because there is memories on that place, there is happiness that you will cherish from the rest of your life. So, that place should be a memorable one for you. So now we will talk about scientific notation wherein we are going to move the decimal point.
So very large and very small numbers can be written more conveniently using the scientific notation. Uh, it is proper to use scientific notation, especially when we have bigger number. Consider the distance between the Sun and the Earth, which is about 150 million kilometers. Let's try to express this distance in scientific notation. This distance can be changed into scientific notation by following the steps shown below. So given number we have 150 million kilometers or 150 million. All you have to do is to move the decimal point in the standard form so that the new number has a value between 1 and 10. Take note that the standard form should be the whole number is between 1 and 10. As you can see, 1. Okay, so 1 or from 1 to 9. Okay, the number should be from 1 to 9. So this will be 1. Then, from here, we will move the decimal places to the right. So how many movement? 1, 2, 3, 4, 5, 6, 7, 8. As you can see, we move 8 places to the left. Again, from here, so we will move to the left to make the whole number be equal to 1 or between 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, we move 8 places. The decimal point is now between 1 and 5. So we have 1.5. Now, so since we're dealing with scientific notation, uh, the constant here is that we will multiply that 1.5 by 10, then we will raise that 10 to how many uh, places we move that decimal point. So how many places? We moved 8 places. Okay. Therefore, our scientific notation for 150 million is 1.5 times 10 raised to 8 or raised to the 8th power. So as you can see, count the number of decimal places the decimal point is moved. That is the exponent to which 10 is raised. As you can see, 8 places, so we raise 10 to 8 power. So if the decimal point is moved to the left, the exponent is positive. So since we move to the left, our exponent is positive. But if we move to the right, something like that, our exponent is negative. So example, the diameter of a red blood cell is about 0.00075 centimeter. This can be written by the following steps shown below. So this will be our given number, 0.00075. So move the decimal point in the standard form so that the new number has a value between 1 and 10. Okay, the value or the new value should be 1 or between 1 and 10. So to make it possible, we will have or we will move this decimal point to the right. 1, 2, 3, 4. Now our new number is 7.5. So this will be 7.5 times 10 raised to what exponent? So since we move 4 times, so 4, and we move to the right, that is negative. So our final answer or scientific notation is 7.5 times 10 raised to negative 4. Okay, so the exponent is negative. Okay, another, or should I say again, given number. We have to make the given number be equal to 1 or between 1 and 10. Okay, so this 0.0075 will become 7.5. How is that possible? We move the decimal point 4 times to the right. So since to the right, that is negative 4. Okay, that obtained number 7.5 multiplied by 10 raised to how many? Movement negative with 4, then to the right, that is negative. Okay, and on the other hand, if the numbers are expressed in scientific notation, we can write them in decimal notation. Okay, so from scientific notation, we will convert or change it to decimal notation or whole number. So take a look at the following scientific notations which are expressed in decimal notation. As you can see, 8.51 times 10 raised to 8. That is our given. Now we will change this to decimal notation. What are you going to do is, from this decimal point, we will move, since 8, we will move 8 times that decimal point. From what direction, left or right? Since our exponent here is positive, so positive 8, we will move to the right. Okay? When the exponent is positive in scientific notation, to make it in decimal notation, you have to move it to the right. So from here, move to the right. 1, 2, 3, 4, 5, 6, 7, 8. 8 places. So this will be our obtained value in decimal notation. So 8.51 times 10 raised to 8 is 851 million in decimal notation. So as you can see, if the exponent of 10 is positive, then move the decimal point n places, whatever the exponent is, to the right. Okay? So positive to the right. Now, as you can see, we have negative exponent on our given. So here, we have to the left. Okay? When the exponent is negative, to the left. So 6.65, then to the left, 5 times. So from here, 1, 2, 3, 4, 5. So this will be our new, this will be the new position of the decimal point. Therefore, the decimal notation of 6.65 times 10 raised to negative 5 is 0.0000665. Okay, that will be the decimal notation of this scientific notation. Again, a negative exponent to the left. Okay, positive exponent to the right. That is from scientific notation to decimal notation. Now write each number in scientific notation. Just pause this video and answer that in a piece of paper or on your notebook. So from decimal notation or whole number, decimal number to scientific notation. Okay, I will reveal the answer. For number 1, from here, we will move the decimal point to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So for number 1, we have 1 or 1.0 times 10 raised to 13. Why positive? Because we move to the left. Okay, that is from decimal to scientific. When we move to the left, that is positive exponent. Okay, next. From here, number 2, 1, 2, 3, 4, 5. So 5. This will be 5.3. That is 5.3 times 10 raised to 5. Okay, it should be 5. Positive again because we move to the left. Okay, so for number 3, 1, 2, 3, 4, 5, 6, 7, 8. So 1.254, this one, okay, times 10 raised to 8. Positive because we move to the left. How about this one? 1, 2, 3, 4, 5. That is 9 or 9.0 times 10 raised to negative 5. Negative because we move to the left. Then last one, 1, 2, 3, 4. That is 5.24 times 10 raised to negative 4 because we move to the right. Okay? So as you can see, all these values are 1 or between 1 and 10. So 1, 5.3, 1.254, 9, and 5.24. Okay, it should be between or 1 and between 1 and 10. Now write each number in decimal notation. So from scientific to decimal, it means that when the exponent is positive, we will move to the right, or when the exponent is negative, we will move to the left. So 1.83 times 10 raised to 3, we will move the decimal point 3 times to the right since it is positive. So 1, 2, 3, that is 1,830. For number 2, 12 times, that is 3 trillion 750 billion. For number 3, 9 trillion 352 billion. For number 4, 6,550. And for number 5, we have 61 trillion 300 billion. Okay? So just check your answer.
To sum it up, so to convert decimal notation to scientific notation, make sure that the whole number is 1 or between 1 and 10, like 1.0, 1.1, 1.2 up to 9.8, 9.9. Then with constant times 10 raised to n, wherein n is the number of movements of decimal point. Example, 1,500. Its conversion to scientific notation is 1.5 times 10 raised to 3 or times 10 cubed. How? So since we have here the decimal point after 0, we will move this decimal point to the left because our whole number should be between 1 and 10. So here, between 1 and 5. So as you can see, 1.5 is between 1 and 10. So 1.5. So how many movements? 1, 2, 3. That is 3. Therefore, our exponent will be 3. That's why we have 1.5 times 10 raised to 3. This is always times 10. Note, if you move the decimal point to the left, the exponent of 10 will be positive. So we move to the left, therefore we have positive 3. On the other hand, if you move the decimal point to the right, the exponent of 10 is negative. So if we move to the right, okay, this is from decimal notation to scientific notation. Okay, this is the decimal notation, then scientific notation. If we move to the right, our exponent is negative. So if we move to the right, we have negative exponent. So how about scientific to decimal? To convert scientific notation to decimal notation, move the decimal point where the number of movement depends on the exponent of 10. So if the exponent of 10 is 3, therefore you have to move 3 times. So note, if the exponent of 10 is positive, you have to move to the right. Okay, if positive, move to the right. If negative, we have to move to the left. Example, 1.5 times 10 raised to 3 or positive 3. This is scientific notation. So, positive 3. It says that positive exponent, you have to move to the right. Okay? So, from here, we have to move 3 times to the right. 1, 2, 3. That is this one, 1,500. How about negative exponent? We have to move to the left. So 1.5 to the left 3 times because we have negative 3. 1, 2, 3. So 0.0015. Okay? So don't worry if you move from a place to another because there's a chance that you are able to go back to the place that brings you joy and memories. Okay, so that's all for today, and God bless.